In this video, we'll discuss the following points and learn a few different ways to think about bringing the creations in our mind's eye onto paper, how to change their surfaces and details, and how to effectively sculpt and carve the designs on paper as if they were a block of clay or a 3D model in a software like Blender. Make sure you spend 1 hour a day practicing the things you learn here until you can do them all. The link for this course's Anki deck is in the description, as well as a link to our Discord server, so that you can help test if this is an effective way to learn these skills compared to more traditional approaches. You can hopefully remember from the start of this video series that we are always best off designing initially in an orthographic view, because we can accurately measure things, and that is still the case. After we design our forms, we can actually very quickly bring them into 3D by simply extruding them. Let's say you wanted to draw a car. What is the best orthographic view to pick for understanding it? This is not always a straightforward question, but for a car, I would say that we get most information about its design from a side view. The plan and front views are useful for sure, but they don't tell us as much information about the body shape or wheel location or anything else we need to really be able to draw it. While having a plan, front and side views is always best, if we could only be given one view, I would choose the side view for a car. It's worth asking yourself this question about other objects too. For example, would the side view still be the most useful for a fighter jet, or would perhaps the plan view be better? The reason you need to ask this question is that if we're given the best orthographic view, it's not hard to set up a plane in perspective and map this view onto the plane. You already know how to do this. From there, we can extrude every line in perspective to make connected planes in 3D space and form an extruded section of this car. This is a fantastic way to very quickly build out the things you want to develop as volumes. From here, we just have to sculpt on or carve off any details we want to turn the volume into more of a car shape. And there are many ways to go about doing this, which we'll discuss in this video. This is actually the approach I probably use the most when drawing things quickly from my imagination. I extrude a rough shape and then I just carve things out, thinking about the ghost form of the object and drawing even the lines you cannot see. This ensures accuracy and makes sure that the design actually makes sense. Sometimes I draw a pre-extruded box to form the volume I want, and then I'll map the orthographic view onto the side of it. And I often do this when drawing things like heads. In the Scott Robertson book, these are called two curve combos, but they needn't be curved. The advantage of them is, however, that for very organic or awkward shapes to visualize in 3D, they can be used to make half of a design and then mirrored across, and this makes them ideal for things like sports cars, where we may want quite an organic design. The process starts the same as before, where we map out the side view of the object on a plane. We then extend another plane along the floor to one side and map out the plan view on the floor. These planes are called construction planes. We can then mark points every so often along the profiles in each construction plane and work out where these points meet in space. This means we have to pull the points on the wall plane out parallel to the floor and then pull the points on the floor plane up parallel to the wall. Now where these lines intersect, we mark points. These points represent the silhouette of the object in 3D space. Depending on the complexity of the outlines on the construction planes, we may need to actually create a lot of lines on certain parts of them to work out exactly how things slot together in space. So don't worry if you have to add a lot of construction guidelines in some areas. Once we have enough points mapped out, we can connect the dots to figure out the object's silhouette. And this takes quite a bit of focus because you still have to consider how your viewpoint and the perspective would affect this outline. And as we've seen before on things like falling edges or very foreshortened parts, they don't always behave themselves. Once we have this volume complete, you can see how it represents half an object. We can then mirror these slices across and set up the reflective view on the other side. We also have a choice as to which side we turn into 3D geometry. I did the side plane for this first example, but tracing over again here, you can see how I could do the top plane. I could even do both planes, and then begin to sculpt into the silhouette and volume using the slices I've created to design the cross-section of each part of the volume. This concept of slicing up the length of the volume into cross-sections is a very useful way to think about reflecting and creating volumes in general. It will allow you to figure out the way that the forms transition between slices, and this is how you make more organic designs. If we wanted to make something like a wine goblet, we can think about the silhouette as these planar slices, and then use our knowledge of ellipses to join them up and finalize the silhouette. One final thing I'll mention here is that curved edges are actually pretty hard to express using just outlines. We tend to need some kind of value or hatching along with good line weight to show how the surface forms bulge or dimple or dip and undercut. Once again, you can look at the artwork of other artists or photos of real objects to see how this might be used. I tend to hatch the surfaces of my forms following the direction of the curves. Another option which works well is to add contour lines across the form. This means just faintly drawing along the surface of your forms to help you and your viewers understand it better. Nothing should be ambiguous about your work. It should be very clearly understood instantly, and so some extra work may be required to ensure this is the case. Do you remember me telling you that it's not really possible to make accurately measured forms in three-point perspective? Well, this method is not perfectly accurate, but it is actually a pretty good one because it allows us to successfully intersect the orthographic views of our designs into a volume. And we can accurately map the orthographic views to the planes we use to set the volume up. And this gives us a pretty good degree of accuracy. You've actually just seen this method being used in 2 axes, but here we're going to do it in 3. Let's say we have in our possession the front, side, and plan view of our object. We can map these to planes set up in perspective, much like a 3D modeler would, and then use the same point projection technique which is played with to work out the volume for the entire object. This is sort of like drawing an object from the inside out, and it's essential to think about the form as a ghost while you're doing this. You use the same exact approach as we did for the 2-axis version, but we swap between pairs of axes now to work out the point locations. This is the same exact approach that a 3D modeler would take, so those of you who've tried this before for making things in programs like Blender should find it easy enough to understand. The downside is that we can't rotate our viewpoint, and we have to consider how things would look from the viewpoint we have chosen, and this is why ghosting is essential. I find I have to add a lot of construction lines when doing this, even for very simple designs like the one in this example. I also have to jump back and forth between considering the different views. Using slices or cross sections can once again be a big help here, and we can place these slices and cross sections at any point on the volume to help us figure it out. The silhouette also needs to be carefully managed, as does any mirroring, and you might need contour lines, values, or hatching, as well as to manage your line weight in order to help your forms feel more three-dimensional. Line weight is actually pretty simple. The thicker, heavier lines feel close to us, so if we have a part bulging towards us, we just thicken up the outline a bit more than the distant parts to make it feel closer to the camera. This takes a little while to do, but you can make some pretty cool designs with this approach, so take your time and experiment with it. There are other ways to think about modeling our ideas though. Wedging is another very fast approach that works better for when you have no orthographic views to work with, or you just want to very quickly mock something up in 3 dimensions on paper. The idea is one you've probably seen before. It's just a case of seeing how each of the 5 primitive forms are used either in whole or in part to make up the objects we see in the world around us. For example, a camera can be broken up into a box with a cylinder for the lens. This is the most simple description of a camera geometrically, but clearly there is a lot more detail to make this look realistic, and the same principles apply here. Every detailed part will just be another box or cylinder or pyramid, cone or sphere, wholly or partially inserted into the main volume. We can use lines to subdivide the parts of our volume and then add any bits we want on by extruding the volumes. These are called Boolean operations in 3D modeling, and they're just as powerful when drawing volumes on paper too. Start with the initial box volume and try to break down the object to its core major forms. From there, think about the next biggest or secondary forms, and finally add any major tertiary details. This prevents you from getting bogged down in details straight away, and it helps you make your volumes feel more grounded in perspective and three-dimensional. I think this is a good one for beginners to use because it's basically the same as playing with building blocks, and this is the reason I think it gets recommended as an approach to drawing in so many art books. You just need to be able to draw the 5 primitive forms in perspective. It's very intuitive, and most people should be able to use it to flesh out basic designs. One other thing to play with here is just wedging primitive forms together in different strange ways. For example, how many different ways can you think of to combine a sphere and a pyramid, or 3 cones and a box? Doing these sorts of exercises forces you to consider how the forms actually intersect as volumes, and you have to draw the lines on the surface of the primitive forms where the edges of both volumes actually collide. This forces you to draw contours on the surface of your form and actually think about everything in 3D, and so it's a very valuable exercise. You don't actually have to create anything, but sometimes these do inspire you to develop some sort of weird character or robot. So objects can be created by wedging together the primitive forms, and while this is a very useful way to build up the volumes you want to express, sometimes you want to cut out and remove material from the mass we have created too. The way we handle this is via projection. Let's say we have something like the side panel of a sports car, and we want to remove the circular area where the wheels will go. One way we can go about doing this is to figure out where the wheels would be placed on a construction plane aligned to the part, and then we can project the points of this ellipse out and onto the body. At the points where these projected lines intersect with the form we have, we can connect the dots and remove the material where the wheels would sit. This too requires you to be able to visualize and understand the forms as real 3D objects on the page, and to be able to draw contours on their surface as if they were real solid objects. For thicker volumes, ghosting is once again essential for managing how the volume you are looking to remove from your form is managed as it passes through. You might have to extend lines and draw a lot of guidelines to figure out exactly where things would be in space, but just remember to use slices and the tricks you know for mapping things out onto a plane in orthographic and you should be fine. The idea of projection is actually very powerful because it allows us to work on very complex and angled surfaces in a relatively simple way. We just place a construction plane anywhere we want, outside or even inside the volumes we want to cut into. If we have a sloped surface and we want to remove a cylindrical volume from it, we can draw an ellipse or custom shape on a construction plane, which represents the orthographic view of the shape we want to use as a cutting implement. We can then project it onto the surface of the volume we want to cut, and you'll see that this method makes it align perfectly to the sloped surface. These sorts of designs are very hard to draw on difficult surfaces, but the projection method makes them much easier to plot. We can not only cut with this, but also add logos, graphics, and any other details to the surfaces of our forms. We don't just have to use these to remove material though. We can also use it to graft on forms in the same way we might with a vacuum former. For example, we can take a surface we've designed and decide on some sort of extruded design or feature we want to have protruding out. This might be hard to figure out because of the view angle, and the surface itself might also be very undulated and difficult to work on. We can design the exact shape we want to project in orthographic view, and then add it to the scene on a construction plane, on the floor in this case. From there, we project lines up and mark the points where they intersect our surface. We can then figure out exactly where this form we are adding sits on the surface and use curves and slices to design it as it protrudes out. And we can even plan this in the construction plane and then project the details of it upwards as well. This is actually the same as the previous technique, but we're just using it to create stuff on the outside of the form now, instead of cutting things into it. It's really no different. The key thing to appreciate is that we can use construction planes positioned in the scene to project 2D shapes onto 3D forms, and then build whatever we want with a greater degree of accuracy. Sometimes we don't want to add or remove an entire volume. We just want to change the surface shape slightly. Good examples of this are seen on products and vehicles, and we can handle this by using curves and slices. Let's say we have a box and we want to change the shape to make it more rounded. We can draw a slice and then redraw the profile of this top face as the curve we want. We can then produce these slices at equal increments down the length of the volume, map how the curve changes between them, and then finalize the silhouette. You could do the same thing with carving out. Let's take the side of this box and carve out an air intake and some panel lines. We can draw this with ghost lines inside the form to plan exactly where the intake would be in space, and then draw curves on the floor and upright planes of this intake to model it in the same way we've discussed so far. We can then just finalize the lines. The secret to this is being able to draw inside the volume and really feel like the lines you are adding are inside it, but then being able to switch to drawing on the volume's surface and really feel like the contours you are drawing are actually being drawn along the volumes of the faces and curves. It takes a while to get this intuition and feeling developed, but once you have it, you'll feel like you're really sculpting volumes on paper, and it becomes quite fast to just change things and add details and mirror them across. There are no sharp edges on anything. Any cars, products, robots, and other characters generally feature no razor-sharp edges on their outlines, and this is another thing that most 3D modelers have to take into account by beveling their models, if only slightly. We should do the same with our drawings. If we have a box we've drawn with very sharp edges, we can draw ellipses onto the corners of adjacent faces, and then think about how we can project these using the 2 or 3 axis extrusions we've covered to actually remove the corner of the form and redefine the silhouette. My preferred approach here is to actually just ghost on a sphere in each corner and use these to define the silhouette. Just ensure they are drawn inside the volume or it might look a bit strange. These are called radiused edges, or bevels, and they do not need to be huge. Sometimes a very slight rounding of the edges is all that's required to make a design feel more real. We can also fillet edges, where 2 faces meet, which is another type of beveled edge. For this, we take a 90-degree angle, and we once again draw ellipses, but this time the tangents on the ellipses touch each face of the 90-degree part. We can then use 1/4 of the ellipse to redefine the corner where the planes meet. Again, this needn't be a huge fillet. Sometimes being subtle is a better design decision. Remember to include contour lines or values to help express the forms changing in the manner you're describing, if it's not obvious to the viewer. The best thing to do here is to just play with each method and find the one that appeals to your natural way of drawing and thinking about form in 3 dimensions. I mix and match all of these depending on what I'm drawing and how hard the view angle is. Can you project a simple orthographic view out into an extrusion? Can you make 2 profiles meet and intersect in space? Can you set up all 3 orthographic views and successfully bring the intersecting planes into 3D to create a volume from the inside out? Can you change the surface shape of your volumes by slicing them up and redefining their profiles, or sculpting on and removing material? Can you appreciate how the objects you can see are made of the primitive forms? And can you quickly reconstruct them on paper? I find that XYZ projections are better for being a little more accurate, but for when drawing quickly and just wanting to get ideas out of your head, you're better off just quickly extruding forms in one axis and then using slices to change their outline, or to sculpt bits on or carve bits off. Remember to ghost your forms and redraw your finished silhouettes onto a fresh piece of paper laid on top where possible. Drawing these perfectly as silhouettes on your first try is possible, and that is my eventual end goal, a lot like artists such as Kim Jong-gi would do. But when learning, it's far easier to use something like a grey marker pen to feel out the volumes and then tighten up the silhouette afterwards. So to recap, you learned that we can extrude orthographic views to make simple forms or use multiple views to figure out very precise intersections of extrusions in three-dimensional space. That we can slice up volumes to mirror them, to redefine their profiles, and work out how the parts of the overall volume transition into one another. And that every object is comprised at its most basic level of wedged together primitive forms, and we can always draw these to get started before adding details. Make sure you can do the following before moving on to the next video. To make the challenge easier, I would recommend drawing referenced objects as primitive forms and then playing with the techniques covered in this video to sculpt on or carve off your own details. Try to change the design in some profound way, or combine parts of different referenced objects together. I do this a fair bit because I find that I still don't actually have enough knowledge of certain objects to be able to design them in a way that makes them feel believable, unless I use references. This is also a great way to think about why the objects are designed the way they are, and you can look into how and why they're engineered. To make the challenge harder, work purely from imagination and try to get ideas from your mind's eye onto the paper as quickly as possible without sacrificing quality. I find that when I do this, my forms come out looking quite cartoony, and I still struggle to think about things in great detail, but I can detail them up once the initial volume is down on the page. This is really open-ended now, and you can spend a lifetime playing with this stuff. It's just about testing yourself and seeing what sort of cool vehicles or weapons or mechs you can come up with, or how to make these volumes more organic and turn them into figures or animals. Remember, all we're really learning to do here is think and express ourselves in 3D to create illusions on paper. And that's all a lot of art is, so it's a base level skill required to eventually move on to things like anatomy, or character design, or vehicle design. Next time, we'll look at some more advanced uses of ellipses to learn how we can further develop our designs and manipulate moving parts. Keep practicing, and remember there is an Anki deck available for free that recaps this lesson and schedules the practice for you. If you want people to practice with, I recommend joining this channel's Discord server, the world's biggest art learning experiment, where you can ask questions, get more challenges, and reinforce your learning amongst friends.